foam effect. I don't know whether it is effective or not. To me, I don't like it. That's all. Let me show my face. Hey. Still at home. Okay. So previously it's discussed about we asking you the treatment, right? Alkaline acid treatment, whether it's affect what actually causing the alkaline and acidic. Remember that? So what actually cause I try to repeat what actually remove the acid what actually removed by acid during a treatment? What is we have lignin, hemicellulose and cellulose. What actually can be degraded by acid treatment? And then what actually is easier to do very quiet? So never mind. We just go through this all is flashback. And I will focus on this later as our pre-lecture. Because when we do our, we restructure our project, our course, we found that previously I studied the factor that affecting the fiber properties is during the iwk205. But when I checked with your lecturers, Dr. Hafiz and Dr. Fazita, then they said that they never mentioned about this in their iwk205. Is it correct? Have you studied about what is the factor affecting the fiber properties? That means the fiber is broad fiber or the fiber is long fiber, short fiber, and then whether they have more lignin or less lignin, what kind of lignin in what wood. Have you studied that before? Can you please recall? Sewa is here.
Yes, doctor.
So I know you study. Do you study that before factor affecting the fiber properties?
I think no. I don't know.
Others? Ma is here. Who is there? Nasuha? Nasuha, Selamat Hari Raya for all the Muslim students.
Thank you, Doctor.
So what is the... I don't think so. Then don't think so, never mind. So we just study. That's why I just put this as a pre-lecture. Before lecture, you should know this. Because if not, then when I mentioned, I thought that you all know. So this one I will continue later. I make it to next. So the previous one, we also study about the bleaching. So while bleaching process is required, as you know, have to recall back, we have to remove the lignin, we have to increase brightness, but at the same time, we don't want to compromise with the fibers strength, because every single, as I asked before, short fiber and long fiber, dye and without dye, which one is stronger? So you have to know that every single chemical bleaching actually will give some negative impact, especially degradation on the material, what material, your hair or your how to say that, something like fibers, same. The chemical process normally will cause a degradation. Okay, that's why when bleaching, we will degrade our fiber. Okay, we degrade on what? Normally in the layman term, that means they are not a technologist, right? You as a technologist, they will say service degradation, or maybe they will say the damage of the fiber, damage of your hair. But you have to know what actually caused the damage. What is the root cause that caused the fiber degradation? You as a technologist, you have to know. Okay, and then why bleach pulp is a brown color, I think you should know. And then what is chromophore? There's this term that you learn in iwk205. Bleaching can be divided into two stages that you know is a lignin removal, lignification, and the other one is lignin preservative. Actually, that one we use as a decolorization, preserving bleaching process. The next one, please remember all this until I have your lab in next semester, that's mean IWA383, you will have a mini experiment that time. So please remember what you learn now. And then evaluating, and then how we evaluate the process that we implement on a fiber is good or not good. So we have to know how to evaluate the bleaching effectiveness. Then we will have our kappa number, and this semester you have your lab, and this lab actually you have to conduct an evaluation for your pulp, not only the bleaching, as also for the pulping, so pulping, whether your pulping process will cause us effective delignification or not, because we also know that chemical pulping also aim to remove the lignin. Okay, kappa number. And the second one is the brightness. The brightness also after pulping process. Sometimes we are not keen to remove the lignin, but we only want to increase the pulp brightness. So the second one is the brightness. Viscosity of the cellulose solution. So that one we call that is a degree of polymerization. This one we will check whether we overreact our pulp or not. Okay, the pulp we over treated, then will cause our serious cellulose degradation. Zero span denser also is a direct method to see our fiber strength have been affected or not. And the last one is see whether the bleaching process that we carry out, whether they are more to delignification or more for cellulose degradation. That's why we have a selectivity checking. Okay, the selectivity index is a difference of the carbon number before and after bleaching divided by the pulp viscosity before and after bleaching. And we study about the bleaching sequence. We know that bleaching cannot be carried out by one stage. So we need to have a different stage in order to remove different component in the lignin, especially the phenolic lignin and non-phenolic lignin. The other one is multi-stage. So that's why we need to have a multi-stage. We use the alkaline, then followed by the acid and alkaline acid and so on. And the interstage washing is important in order to remove the degraded lignin. So when we wash, we will minimize the next stage chemical consumption, because it's more effective to remove only the lignin remain in the pulp, not the lignin after degraded, but reattach on the fibers. Okay, this is what we call that is after when you see in IWK103, I hope that you still can remember what actually this graph is showing on is for what. So you can explain that there is a chemical consumption after some limitation over here. Then the continue. Continue the continue the the deification of brightness increment. But after one level of the lignin charge, the chemical charge, the lignin removal or the brightness increment will be limited. Then we have to change another stage. So and so on. That's why our bleaching sequence normally they have more than 3 stage, or 3, 4, 5, 6. So cannot be only one stage to increase. That is a flashback for 103. And now we go on for the pre-lecture I prepared before. Okay, this is one. This one you already available in the e-learn. Just I try to convert this into PDF file, but maybe some of the words like this is not readable by PDF. So I have to change all the words. I have to change all the font before I can convert into PDF file. So pre-lecture, that means this might be included in the lecture, might not. But it's a basic or fundamental knowledge that you should know when we go for this. Okay, factor affecting the fiber. Actually, for this chapter, what we want to learn is about how the fiber affecting our paper properties. Okay, so when you work in the paper industry, not only paper industry, others like your fiber board, you are working on the cellulose and so on, you have to know what actually the raw material, the factor of the raw material affecting the affecting the what? Affecting the end product properties. May I do a survey with you? Because you already now you are the third lectures for pulp and paper. Pulp, the third lecture, the theoretical lecture for pulp paper technology. Do you feel that paper lecture is too many? Can you give me a, because I just have a acid acid survey from your senior. I found the suggestion or the feedback from them. One of them is saying that it's quite negative, but I accept it. Uh, because they said, paper subject is too many. Do you agree? We have 3 lectures: IWA 103, IWA 203, IWK 203, IWK 205. And then we have 2 practical lab: IWA 283, IWA 383. Is it too many for you about paper properties? Actually, and the other comment disagree. And the other comment is they said all the subject in our program is very discrete. Discrete, that means satu biji, discrete. Not continue, not connected, except for paper. This is quite positive, except for paper. It's quite have a link. So that is quite positive. For me, they said 2 paper is too many. Actually, I let you all know when my lecturers, the father of the bioresource paper and coating, that means wood paper and coating, is a Prof. Wan Rossi and also the engineer Abu Sama. When they designed this course, we have bioresource paper and coating, right, or wood paper and coating. So all would have 3 subject theory: 100, 102, 202 and 302. But when we try to restructure the subject, we cannot use back the same. When we start to use bioresource, we have to use we change the name. Only 102 didn't change the name, and 202 changed to 105. That means it's a continuum of a bioresource course. And the last one is 308, mechanical kayu, engineering kayu, but now we change to another is a material. So actually they have three theory classes. And for the coding never changed: 101, 201, and 301. So all equally. But unfortunately, because paper is quite paper look and also continuous, so people will have a concept that paper subject is too many. But never mind. We just accept it. The design is like that. I can't change a lot. The only thing is you always see me. That's maybe lucky for you. Okay, so we continue to the pre-lectures that I hopefully that this will open your mind how actually the fiber are different. All the plant have the fiber. While when we use different raw material to produce our pulp or to produce any fiber-based panel or product, they will give a different properties. Okay, so we have to study the root cause. So now we discuss about the factor affecting the fiber properties. Understanding the influence of source, the structure, the processing on the fiber characteristic. Okay, the overview. So fiber properties are influenced by fiber source and the origin, structure differences such as early wood, late wood, and so on. Maturity of the fiber, such as whether it is a juvenile or mature fiber. That is mean the young fiber or the old fiber. And the tree location. And the last one is the processing method. How we process the pulp. And maybe in the last stage, I can share with you what I experienced when I creating project for KNAF under the LKTN grant. So I will use my experience. Hopefully, I can share with you something. Fiber source. Okay, for the first one is fiber source. As we know that we have different style of tree or the non-wood fibers. So type of source, whether it's a softwood, hardwood, non-wood, something like sugarcane bagasse or oil palm tree lah, jute lah, and then the kenaf core, or kenaf fibers, or the pseudo stem banana. You know what is pseudo stem banana? Pseudo stem banana, that one. And also we have maybe like sisal and so on. We have paddy straw or rice straw and so on. We have different sources. The fiber that we get actually different. For software, we know that software is longer fiber, hardwood is shorter and broader. Downward, there are various, like bamboo actually is quite strong, comparable to the softwood. And that oil palm pulp is actually is very short, is comparable to the hardwood. And the other one we can say, the paper you produce, whether it's a virgin pulp or secondary or recycled pulp fiber, that will also our paper properties. In here, I know that the fiber can be used for many products, but here I will more concentrate on the paper quality or the paper product. So this is a source of fiber that we use. The second one is a morphological difference. Morphological difference, that means the fiber can be different length, different diameter or cell wall, and also chemical composition, varying from the cellulose, hemicellulose, lignin, and extractive content. So some fiber, you can see that. Do you know about the kapok? Kapok is an English name, but in Bahasa we call that is a kekapu. Kekapu. Sekarang ada orang guna kekapu untuk isi pillow tak? Siapa pernah? Ada orang lah pernah tidur dengan kekapu punya pillow. Ada lagi ya? I just want to see. Yes, Atira, you raise your hand? Yeah, you are the one who used before.
Yes.
Yeah, so kekapu. Do you think what is the difference between the kekapu and kapok? I think our ancestor is quite very, how to say, smart, they're intelligent as compared to our generation with high technology. I really admit that the ancestor is the earlier generation is more, how to say, is more intelligent than us, smart. They understand the nature than us. Have you seen the kekapu? Anyone have never seen kekapu before? Then you can give me a response, please. Any response? I just want to see who never see before. You can put an emoji lah that you don't know. Never. Anyone never see the kekapu before? A kapok? Then later we go and kutip kekapok on the floor. Anyone? Sorry. No ah? Ada tak? Tak ada emoji, tak ada apa-apa. Tak ada orang. Hey, you all online or not? Mak pernah tengok? Ada yang tak pernah tengok? You give me boo. Boo one, you never tengok. You never seen that one before. Tak ada orang. So what is the Ma, I saw you. So what is the difference between the kekapu and the benar? Ada pokok kekapu kat taman kamu. Kutip some for me. Bu. Or what? You pernah tengok? Okay, it's very interesting. You can check. Kekapu boleh basah tak? My question is, kekapu actually is quite similar to cotton, right? Quite similar to cotton. Only you said that it's yellowish, macam tak berapa putih, macam cotton sikit, right? But kapok is used to absorb water, right? Kekapu can absorb water or not? Very, very interesting. Can kekapu absorb water? Ama, you rumah ada, you no, no, Abu said no, never. Boleh. Ama kata boleh. You tengok kekapu ada tak? You boleh absorb water tak? I bagi tengok Saya cari lah, nampak saya boleh ada petas itu tak? I hope that I can find the paper for you. Wait for a while. I stop sharing now. I find one for you to see in the internet. Kapok additive lay done. This is my own paper. I let you see. Hopefully, I can show you the gambar lah. The gambar is here. Wait. Accept all cookies. This is the gambar inside. I show again to you. Okay, can you see my my screen? Okay, this is my own paper, my own paper. This is my own paper. You have time, you can go and check. You just put the cyber pentantra. Good. That is kapok lah, carboxyl fiber as a, actually it's carboxyl fiber, I'm wrong. Actually it's carbon pot fiber, seed pot fiber. Okay, seed pot fiber. This is gagapu. When you put on the water, this is water, is floating, you know. You say tak boleh absorb, tak boleh no, never absorb water, and we have to do some treatment in order to change its hydrophobic. Hydrophobic become hydrophilic. Okay, so we increase the hydrophilicity by only dewaxing. We just watch it, so we can absorb water. At least it can soak halfway lah. Okay, soak on the fiber. So we use it as a fiber to recover the fiber. To reinforce the recycled paper properties. So we said that we are using it as a recycled paper reinforcement part. Okay, so that's why I can share with you. Okay, go back to this. And as you can see, okay, cardboard and also the cotton seem like similar, but they are different. And then our ancestor, our early generation, we use the kakapu as a stuffing material for our pillow and other application. So maybe in the very temperate country, when they have winter, they also use it. Why not cotton? Why not cotton? Why we use cotton to make our textile, but we not use the gap and did not use the cotton to stuff our hero. But nowadays, they will say in the supermarket, you can check in the market, they have a cotton filled pillow. But for me, I won't buy it, even though I support the things. I support even though I support natural fibers, but I won't buy pillow made from cotton. The only difference that I would choose kapok filled pillow, but I not choose the cotton filled pillow, because cotton will absorb water. Cotton will absorb water. When we're sleeping, don't say you sleep in a very, very low temperature room. Normal sleeping, we will sweat. If you use cotton, that means they will absorb all your sweat. For me, there's less hygiene. But if you use pillow, the carbon fiber actually they won't absorb your sweat because they are hydrophilic. For me, carbon filled pillow is more hygiene because you just need to change your pillowcase. It's not the cardboard itself, the stuff material, because the stuff material is similar to your plastic. Plastic have the electrostatic. This one is a natural fiber, no electrostatic, so you can use it well. Okay, but you won't absorb. So because this is not and this cotton, this is one of the differences. The second difference, that's why we also cannot use the cardboard directly to produce paper because it can't absorb water, so cannot be form the hydrogen bond. That's why when I want to use it, I have to treat it first. Cardboard, actually, I learned a lot of things when I start to use the cardboard for the as a source for pulp. As a source for pulp. When we learn later, I will mention to you. Maybe before that, I will mention when I do beating or popping on cardboard fiber, I found something. Okay, but cardboard first one is hydrophilic, hydrophobic for cardboard, hydrophilic for cotton. The second one is you see the yellowish color. Yellowish color actually, the leading content for the cardboard is quite high. It's about 16 to 20. That's quite similar to hardwood. But cotton is 90%, 95% is the cellulose. And the second one, even though the cardboard containing 80% is the hollow cellulose, but it's containing more hemicellulose compared to other raw material. Cardboard containing 51% is the cellulose, 49% is the hemicellulose. But normally the AFP containing 60% is the hollow cellulose and 40%, 60% is the cellulose and 40% is the hemicellulose. And for the cotton we use it as a source for the dissolving pulp. So that means its content above 90% is the cellulose. That is a chemical composition difference in the various kind of the fiber source. The last one is its physical properties like the density, the coarseness, the fibril angle. And the coarseness is related to the fiber cell wall, the thickness of the fiber cell wall. Physical property including the lumen. The lumen is big or small. The diameter is big, is a very broad or very small. That all will affect our paper properties. Okay, but now we just want to see what actually will changes all this kind of the differences. Fiber source, fiber source. So I can't change. Okay, you can see we have one is lakewood versus lakewood versus the earlywood fibers. This one is what kind of pulp? It's softwood or hardwood? Anybody can tell me? Atira, you want to say? This earlywood, lakewood, this is what wood? Softwood or hardwood? This photo show hardwood or softwood? Atira,
Softwood.
softwood, right? Why? This is what? Wait, this is what? What you can see? This cell is called what? Atira, you ask your friend to answer for you.
Please answer someone.
You call him, but I call you.
I can't see any names because my screen, I cannot see who's inside here. Anyone
So
wants to
after
answer?
you, I ask Aisha. Aisha, Yasmin. Just said this is hardwood or softwood. I decided already this is softwood. This call what? This cell we call what? Aisha. Fang Yin. This what cell? What cell? What cell is this? Fang Yin? Fu Fang Yin?
Yes, doctor.
What is this? What? How to call this cell?
Um,
This is softwood, right? Softwood cell, what is the name? Start from T.
Trachea.
Yeah, this is trachate. So only trachate, only the softwood we can see the late wood and early wood fiber. So when we how why this the softwood can appear like growth ring with the very apparent late wood and early wood? Because of what? Because of what? This because of what? Hua Yong Kang. Yong Kang? Participants. Anyone can please share in the chat box about the attendance key password. Please copy and paste for them. If not, I have to spend my time. Thank you, Adira. Please, if you come late, please go and take your attendance. Yong Kang? Jason? What actually causing the softwood have the late wood and early wood? Yeah, Chong Kang said what? I just want to check the message. Message. You can't open my, you can't open my, say, you just give me the answer lah. Jason? Don't type that, you also cannot open mic, you just type the answer for me. This is trachate. What actually causing the softwood have the late wood and early wood? And from the cross sections of the wood, we can see it as a growth ring, right? It's a growth ring, right? So what actually causing it has a late wood and early wood? Jason, Yong Kang, siapa lagi ya? Tak boleh buka banyak sangat. If I open too many, I can't see my screen. Ask Lina. Alif Hakimi. So please, anyone? Very low response. Ada orang dekat sini ke? Siapa dekat sini? What actually causing temperature change? Diameter. Cambium makes cell larger diameter and the cell grows smaller in diameter. Among what is that? You mean temperature change? It's due to what? Temperature change due to what? Station? Start from S, right? Season. The late word is due to the season. The season actually make the software have the late wood and early wood. The late wood is what season? Which one is winter? Which one is the spring? Growth cell. Early wood spring. Yes, early wood spring. Thank you. Ready? So when the water is a lot, when the season become hot, the cell will grow faster. The cell will grow faster, and that's why the cell lumen is bigger. But during the winter time, the growing rate is very slow. It's very slow. That's why the cell will become thicker and the lumen is very smaller. And that's why when we change the season, when we change from winter to a growing, faster growing season, that's mean we can see the changes of the cell. So that is what we can see. Thicker cell for the legwood, a smaller lumen diameter, and high rank ratio. And early wood is a thinner cell wall, larger lumen, and more flexible. The other one more thing is Zuvina and also the mature fiber. Juvena fiber is from the inner growth ring, first to 10 years, and the shorter, thinner cell wall and low strength. Lower strength is because the microfibrill angle is smaller. Have you know about the microfibrill angle before? I think Dr. Hafiz has discussed this with you. Is it microfibrill angle? Have you heard this before?
Yes, doctor.
Yeah, right. So microfibrill angle is majorly is refer to the microfibrill angle of the F2 layer cell wall. That means there is more smaller cell wall. That means the fiber is more arranged to vertically. The larger microfibrill angle is from the normal line to the angle. That means it's more to horizontal, but not until horizontal. That means the angle is bigger, more sliding. So when the fiber is more sliding, that means that will cause the fiber become lower strength. The other lower strength for the Zovina fiber is because the thinner cell wall, thinner cell wall. Okay, and 1, 2, and the next one is what? 1, 2 factors, and then they have another factor affecting the fiber strength, lower fiber strength. There is one is caused by the cellulose degradation. Then we discuss this later. Mature fiber from outer ring, there's after 12 years, and a longer fiber, thicker cell wall and higher strength. And age dependent variety, there's okay. There's all depends on the age. Okay, and next one is the effect of tree height. So lower trunk fiber, upper trunk fiber, and then lower trunk fiber, they're generally longer and stronger. The upper trunk tends to be shorter and also the finer. Okay, I just recall back last year, September, I attending a LKDM annual conference. Every year they have a conference, and then most of the researcher will present their paper. But that time I make a businessman. He talked to me. I really want to. They use their let me understand. So for a tree, for any kind of tree or plants, when you cut, you chop the stem. Okay, the stem or the trunk, and you start how the fiber grow up. They will grow from the bottom, the trunk will up like this, or they will grow another one from the center and grow and the new one for you. And after you cut, they will continue growing up. The cut one will be higher, higher, higher. Or the cut already cut, okay, cross section you cut already, and then from the center they will grow the new branch. So the bottom one is still the bottom one. They won't increase the height. The bottom one is still the bottom, but the increase the height actually is new branches. A or B? B is the new branches. A, the trunk will be growing up. After you cut, the height of the layer that you cut, you're growing up. A or B? B, that means you're all from bioresource. Yes, he tell me that the trunk will be improved. The old one will be continue to become the younger one. So you know the lower trunk that will start from lower, the upper one normally is a young one. So all the time the top one will be the young one because only the young one is growing up. Okay, the top one will become the foundation. So there's one. So the lower trunk normally is old fiber. There's one is longer and stronger. So and the upper trunk of the trees, there's tend to become shorter and finer. That means it's the difference become the juvenile and also the mature fiber. So variation in the properties along the height of the tree. So when you cut the tree, you know we normally only use the center. So from the bottom up to the center, the top one we don't use because that one is the short fibers. And also the branch. The branch also have a shorter fiber compared to the trunk fibers. The next one is treatments. Treatment fiber, the effect of treatments. So before that, we talk about the difference area or difference upper or lower trunk or the branches. Now we're talking about the effect. The effect we study, I think during 103, I mentioned to you about the dissolving pulp, right? Dissolving pulp. So the dissolving pulp that we use is not for paper making. We want to use this as a cellulose dissolving cellulose or cellulose chemical. We use it something like a chemical because this is very pure. We want to produce some nanocellulose, microcellulose, cellulose acetate, and any type of those regenerated cellulose, something like the cellophane tape, cellophane, or even the rayon. We use dissolving pulp because dissolving pulp contain the cellulose alpha cellulose more than 90%. But for normal paper, we don't want high cellulose content. We just want sufficient, and then with the with some part actually is contributed by the hemicellulose because hemicellulose is needed, is required for paper making. So if you remove the hemicellulose, that's mean one, we will reduce the yield. The second, actually, we also reduce the paper quality because cellulose will only have the OH group to contribute for the hydrogen bond. But the hemicellulose actually, they will provide another side group, okay, functional group that is carboxylic acid group, COOH, carboxylic acid group. That group will provide a stronger hydrogen bond compared to the hydroxyl group. That's why the hemicellulose is needed for paper making process. This one we will discuss again in the next coming chapter. Okay. So pre-treatment with water and acid solution performed at the elevated temperature, reduce the hemicellulose content, especially by using water or acid. A hemicellulose is a short fiber. Okay, anybody? I think that last lecture we discussed about the difference between the hemicellulose and cellulose, right? Am we? So difference between the cellulose and hemicellulose. Yes or no? Kevin, is it yes? No? We discussed about the difference between the cellulose and hemicellulose. Cairo? Semua ada dalam lecture tak? You all in the lecture room or not? Hello? A bit only? A bit only? What is a bit? What do you know? What do you know? Huh? You don't know what is my question, Kelvin? Where are you? Coming? Kairunism? What is my question? Have we discussed the differences between the cellulose and hemicellulose? My question is, do you know what, or have we discussed, or do you know what is the differences between the cellulose and hemicellulose? What is the time now? It's the time to have a break. Yes, almost. I give you 5 minutes break. Okay, we break for 5 minutes. Then you give me the answer after this. Okay. I stop record now. Then we come back at 11. Okay. I also stop my video. We start again. It's okay, ready? So continue the first same question. What is different between the cellus and hemicells? List out one by one. Check cellus, beta cellus, hemicellus, xylus. Yoranda. Okay, I have some answer over here. Amma says cellus long chain polymer, hemicellus cross-linked polymer. And cellus is beta, cellus, hemicellus, xylus, mannose, and galactose. So combine these two. What else? So thank you, Amma, and also thank you, Yoranta. But I just want to do a little bit correction. Yes, cellus is long chain. That means actually beside long chain, actually cellus is a linear polymer. If you want to become hemicellus is not you can say cross-linked, or we can say that it's a branch chain polymer. That means they have a lot of branches. And cellulose is a linear polymer. The second one, you can say that cellulose, okay, beta glucose, right? Yes, cellulose is a homogeneous monomer that is built from the monomer that is built from that is built by the glucose, and the hemicellus is a heterogeneous sugar unit built by the heterogeneous sugar units that might be xylose, mannose, galactose, arabinose, and sucrose as well. Okay, there's a differences, two differences. The last differences is what? The last one? Actually, should not be the last one, but I just want to say, you want to give me the last one? That actually causes that causing that hemicellus is easier to be reduced, to be degraded by using the water and acetate under the high temperature process. Two more. What is that? Causing the hemicellus easier to be degraded. Anybody want to answer me? Cellulose is hybrid or homophos, and also the crystalline structure, while hemicellus is a composed of the amorphous. Yes, hemicellus. Thank you, Kelvin. So hemicellus is composed of the amorphous structures. That is why it is more loose compared to the crystalline structure of crystalline region of the cellulose. And this more causing the hemicellulose accessible, easier to be accessed by the reagent, something like the hydrogen hydrogen ion during the hydronium ion during the hydrolysis process. And the other thing is repeat the degree of polymerization, the repeater number of the monomer. That means is this degree of polymerization. For the hemicellulose is only 200, but for the cellulose is can up to 10,000. Okay, up to 10,000. So due to is amorphous because of branches content, so hemicellulose is easier to be removed under the pretreatment process. If we have a pretreatment like water or acidic pretreatment, then the cellulose can be degraded. And in during this time, we degrade mostly is the hemicellulose and partially of the water soluble lignin. Okay, and when we use this pre-treated pulp, pre-treated raw material to further undergoing alkaline pulping, we will produce the dissolving pulp. Because dissolving pulp, we need to have a higher lignin content, because 70% up to 70% of the hemicellulose can be removed during this pre-treatment by using water or acid. So when we produce pulp, we will produce a dissolving grade pulp. Okay, dissolving pulp. So that is a difference of raw material. Dissolving pulp is not for paper production. Okay, dissolving pulp is not used for paper production because this kind of pulp does not contain the hemicellulose, and this will cause to the yield is very low, and this will increase the production costs. Not worth to use this high purity dissolving pulp to produce paper. And the other one, technically, without the presence of the hemicellulose, the paper they will produce is insufficient strong. Okay, insufficient strong. Okay, second one is the pulping method. As we study or emphasize all the time, chemical pulp and mechanical pulp. So chemical pulp, actually we can use acid, alkaline, and neutral in order to do the pulping. So that will affect the fiber degradation and degree of polymerization. So if severely causing the degradation by using the acid, then the fiber cannot make a very strong paper. You remember that craft, what is the meaning of craft? Still remembering the craft pulping or not? What is the meaning of craft pulp? Anyone still remember? Anyone still remember what is craft pulp mean?
Strong pulp.
Hello, Dylan.
Strong pulp.
Yeah, chemical pulp. Huh? Chemical pulping methods, yes, craft pulp is a type of chemical pulping. What is craft mean? Kraft.
Strong.
Strong, yeah, strong. Craft pulp means strong pulp. Craft means strong. Why strong pulp, you know? Before that, actually, if you study about the history about pulping method, in the beginning, they use the acidic pulping. They use acidic pulping first. And in the very beginning, the craft pulp is not very popular. It's not accepted by the industry or the normal people, the user, the consumer. Why? But the craft pulp, until now, the craft pulp is still contribute to 70% of the chemical pulp market. 7 to 75% of the market. Okay, the pulp market. That time in the very beginning, the craft pulp is not that acceptable compared to the soda and also the sulfite pulping. Do you know what is the reason? There are two reasons. If we study the history, we study the paper properties. There are two reasons. The first reason is the color. In 103, we study about the color. I did mention before, craft pulp is a very dark brown color pulp without bleaching process, and it is quite hard to bleach in the high brightness. But after when the inventor invented the chlorine bleaching so that we can increase the craft pulp brightness, and that consequences the craft pulp can be accepted widely. Okay, high acceptance. But before that, no. Even though it is a strong pulp, even though it's a strong pulp. Strong pulp is very important for packaging. Okay, now we go back to this question. Okay, before that, when we use sulfide pulping process, the pulp actually is brighter because they won't have the alkaline darkening effect. So acidic pulping, the pulp is very higher brightness, but at the same time, it has lower strength. If you combine with what we discussed before, carbohydrate is easily to be degraded under acidic condition. Carbohydrate like hemicellulose and cellulose as well can be hydrolyzed under the acidic condition. So when we use acid type pulping method, so the pulp we produce is weak as compared to when we use alkaline pulping process. Okay, alkaline processing alkaline pulping process also depends on what kind of the chemical that you use. Either it's soda pulping or craft pulping. If soda pulping, they only have the OH group that will also cause the alkaline hydrolysis for the pulp and causing the cellulose degradation. And also the pulp produced was the soda pulp produced has a lower strength compared to the craft pulp. They have a lesser amount of hydroxyl group because part of it we use sodium sulfide. Okay, sodium sulfide. There's a S will be replaced by the OH group, and they will cause lesser cellulose degradation. So that's why when we use acid, when we use alkaline, different alkaline, the strength of the fiber will be different, and the color also will be different. That depends on what we want to produce. And the next one is what kind of the pulping method that we want to use. Chemical pulping, mechanical pulping, or the semi-mechanical pulping, semi-chemical pulping, or the chemi-mechanical pulping that we want to use. And all these pulping method will vary our fiber lengths. Okay, if long fiber like the softwood, okay, softwood you use chemical pulping, it's a remain long fiber. If you use hybrid, that some of the mechanical process can shortening the fiber strength, fiber length. And if you use mechanical pulping process, normally the fiber length will be even shorter because the mechanical process can shorten the physical fiber length. I repeat again, mechanical process can shorten the physical fiber length. Why I want to mention physical fiber length? That's mean the whole fiber cell, the whole fiber cell that you see, that you can see the tissue paper will tear off. You can see the fiber length. Physical fiber length can be shortened by mechanical process. But before that, we studied about the chemical part, right? Degree of polymerization. Degree of polymerization is the repeating unit of glucose in a cellulose chain. That one you can see. Chemically will shorten the cellulose chain by degrading the cellulose chain. Okay, the repeating unit become 10,000. If you randomly cut in between, will become 5,000. So immediately will reduce the fiber strength. Will reduce the fiber strength. So that's why mechanical process, chemical process, they will give a different effect to our pulp. Okay, last one is the bleaching that we mentioned during our IWK103 bleaching process. So we have to use lignification bleaching process. Either you order the lignin content or you may remove the hemicellulose. Always. Okay, let's say now you say that you want to use recycled paper to produce a microcellulose or nanocellulose. Do you want to use the office paper, or you want to use the what office paper, or you want to use the other one is what newsprint? Why newsprint is harder to produce a nanocellulose compared to the recycled chemical pulp, like for A4 paper? Any answer? Penny? Lim Penny? Ikram? Mama Ikram? Penny? Can? Anyone? Answer me please on your mic. I don't care any. Yes. Just now I listen someone is open on the mic. Penny, can you please repeat? Can't hear you. Ada orang nak answer tak? What is the difference between the A4 paper and also the newsprint?
A4 paper use chemical. Newspaper use mechanical.
Newsprint using mechanical. Oh, who is answering me? Dylan. Okay, you are saying that A4 paper is chemical pulp. Newsprint is mechanical pulp. So what actually is the difference between the mechanical pulp and chemical pulp? Why we cannot recycle the mechanical pulp to produce nanocellulose or microcellulose? Why?
Because high lignin content.
Lignin content, yes, it's a different in lignin content. If you want to recycle the newsprint to and to produce nanocellulose or microcellulose, that means you still have to remove the lignin because the pulp that we use to produce the newsprint is mechanical pulp. It's still like wood containing pulp. If mechanical pulp, we call that as a wood containing pulp. We still have to go through a lot of process in order to purify the pulp and obtain the pure cellulose. But chemical pulp, most of the lignin have been removed. Okay, most of the lignin have been removed. Then we have to clear off what? Clear off the non-fibrous material that we add on to the paper production. Maybe the starch and so on, the filler, and so many. Maybe some is a functional filler, like the titanium oxide, calcium carbonate. That is not the fibrous material. Add on the additive to the paper, we can remove. Then we no need to do any bleaching. Okay, we don't need to do any bleaching because the A4 paper, recycled A4 paper is pure, is actually is free from lignin. And the other thing we have to remove is the hemicellulose. Then we have to further remove hemicellulose from the recycled paper. So when you choose the pulp, you have to understand what kind of bleaching process has been experienced by the recycled paper. Then we can decide how we can treat the fiber in order to produce a new product from this recycled or secondary raw material. Okay, the second one, changing of bright. So this is a bleaching process, whether it is bleached or unbleached. Another one, if you want to produce hemicellulose or no, you want to produce the microcellulose from the craft pulp, also quite difficult because the craft pulp, something like for packaging material, they haven't go through the bleaching process. Then they might contain the residue of the lignin, even though it has been gone through the pulping process, chemical pulping process, but it's still remaining part of the hemicellulose and also the lignin that cause the fiber have a impurity and the low brightness. The last one, chemical treatment will affect our paper, the fiber properties. And the last one is the mechanical processing, like beating and the drying process. Okay, beating process will increase the internal and external fibrillation of the paper, of the fiber. So that's why we can produce nanofibrillated fiber, nanofibrillated cellulose. After we produce the dissolving part, we can go through the very severe beating process in order to enhance the external fibrillation until there actually is a few nanometer filtrate outside the fiber. Then we call that is a nanofibrillated cellulose. Okay, we can use it for paper. We can use it for others composite as well. Okay, enhance the fiber surface area and bonding. That is what we want, but for other purpose has a uh different objective. The other is a drying process. Whether your pulp is dry, bone dry or not bone dry. Okay, dry fiber until the 85% to 90% moisture content loss will become stiff and hardened to be discharged. Due to what? Anybody give me the term? What will be experienced by the fibers? Very fast. What will causing when we dry the fiber? iwk205. Dr. Kushaidi. What is that? What's that? Huh? You want me to call him? Yolanda, hornification. Thank you, Yolanda. Yes, hornification. Drying process. Can you hear me? My network is not that good. Can you hear me?
Yes,
I
Doctor.
reshare again. Yes. Can you hear me? Yes, because there's now a signal saying that my line is not good. Okay. So even the wood, like enough is even EFB, even if the bond dry already, we dry it when we cook, the result is different compared to the wet raw material. That means the never dry raw material. It's very obviously is a canaf. We have an old canaf before, and then I can't get very there. I think it's keep for 2, 3 more than 2 years or 3 years. The result is very bad. Then I said I can't reach the targeted result that I want. So I asked the LKTN, the Lembaga Kanaf, and also the Lembaga Negara LKTN. I asked, can you provide me the fresh one? So they directly cut the new fresh Kanaf and sent to me. Even though within 2 to 3 weeks after we cook, we found that the result is totally different. And then the fresh one easier to cook, and then the leading content is lesser. If you dry it, sorry, the hornification not only happen to the fiber, I think that they're also causing the effect on the raw material. I think that is only until now for this. The summary for today is fiber properties are highly variable depending on the origin, something like the source, the part of tree, whether it's outer layer, inside the layer, or whether they're on the top or the bottom. And also like Kanaf, you know Kanaf, right? Kanaf have the bast fiber and also the core fiber. The core fiber is quite similar to the hardwood, and the bast fiber is more quite similar to the softwood. The difference is only the physically the fiber for the bast is longer but containing less lignin. For softwood, they're containing long fiber but high lignin content. For the core, short fiber but more lignin content. Compared to the hardwood is short fiber but less lignin content. Okay, there is a difference, but physically, bast is similar to softwood with long fiber. Okay, the other one is maturity. So for tree that if you want to have the plantation for tree like we use eucalyptus, Eucalyptus, you know double A, right? Double A is using eucalyptus. Double A is a Thailand company. Thailand company. The company is located in where? Where you want to go? Normally you go Thap Yai, and the other one is Songkla. 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 Uh, Double A is located in Songkla, the factory. So they use the eucalyptus. Last time they have to plant it for seven years, but now I think they shorten it for 5 years. Difference. Eucalyptus is good fiber, hardwood fiber. But they have also advantage is the grow rate. The grow rate is very fast. Grow rate is very fast. It will cause that they absorb a lot of water. Competing if you plant between your what was that other plants like paddy or whatever, they will absorb the water from the earth a lot. So they have to control to plant the eucalyptus as well. Okay, maturity. So you can't say that I want to cut 1 day, 2 days. No, that depends on the maturity of the fibers. Depends on the growing year. Okay, pumping and mechanical treatment. Okay, whether the pumping method, whether you use it mechanically or chemically, the chemical that you use, acid, alkaline, or neutral, they will give different effect on the pulp that you produce. Okay, the last one is more mechanical modification. We use this as our beating process in order we produce, we will cause the external internal shortening of the fibers. Okay, there is a beating process and drying also. We cannot bond dry our fiber before we do any treatment because it will very significantly affecting the process efficiency. So understanding this factor is critical to optimize the paper and pulp properties performance because we know that the fiber that we project is directly affecting our paper properties. That is the first part for this. And then I continue and half an hour for our first chapter. Thank you. I continue another lecture, sir. Okay, chapter 1. Can you see my lecture? This is the first chapter. Okay, basic properties of lignin cells and their effect on fiber properties. Do you see this? This is not charting. This is not charting in your dummy. This is SEM, scanning electron microscope of EFP fiber, of EFP sorter pulp. What you can see over here, actually, this is chemical pulp. Chemical pulping process, normally they can remove the primary cell wall from the pulp. And then you can see that this is a microfibrill angle. All you can see is small line that is microfibrill. Okay, microfibrill. This is fiber. And you see this is 20 micrometer. That means this is about less than 10 micrometer diameter. Micrometer diameter. Actually, this is the...
I cannot see the slide, doctor.
You cannot see the slide. Very sorry. Sorry, thank you. I thought I shared already. Okay, this is a fiber. Thank you. This is, you can see something like charting, right? This is not charting. This is chemical pulp using SEM. You can see so long ago. That is my student, my first batch student. They study about the chemical pulp from EFP. Okay, this using the scanning electron microscope. So you can see that is a fiber alignment, fiber arrangement or alignment. And then you can see there's certain anchor. There's a microfibrill anchor. If the bigger one, normally they're still containing the primary cell wall. So you can't see very clearly the alignment of microfibrill because it is randomly arranged. Primary cell wall is... Okay, that is what is a basic properties of nanocellulose fiber and their effect on paper properties. Okay, what we want to study about the fiber length, fiber thickness, fiber coarseness, fiber density, microfibrill angle of fiber cell wall, specific surface area of the fiber, fiber sparing, fiber flexibility, and fiber curve will be covered in this chapter, chapter 1. And in the end of this chapter, I would like to discuss about how this kind of fiber properties affecting our paper properties. This is very summary of the whole course, actually. How the paper becomes stronger, why the tearing strength, tearing resistance is become lower after the mechanical treatment, and then chemical treatment, why the no, sorry, optical optical properties of the fiber, why the paper become higher opacity or lower opacity, higher brightness or lower brightness. All actually is about fiber properties. Okay, fiber properties. Okay, fiber length is the first one. Fiber length is the longest measurement dimension of the fiber, which is determined from the end to end of the fiber. Okay, fiber length is varied by the original source that we studied before, huh? Something like this all fiber mature Zurina, the fiber source location, and cowpark that we already studied before. Okay, in the period chart. There is some the fiber properties of different source. You can see this is softwood. Softwood, these two, the first two are Angle and Eagleman also, Splash also the same. It's a softwood. You can see the fiber length is more than 2 mm. Bamboo is more than 2 mm as well. Okay, but it's non-wood. For hardwood, normally it's around 1 mm. And Knauf core bars is a low. Bars is 2.8 and then core is 0.8 that I mentioned just now. So this is all the paper properties from different source of fiber width, also different thickness. So softwood have a thicker cell wall compared to the softwood. Depends on the what the species as well. You can see eucalyptus has a thicker cell wall. Okay, Knauf bars 6.2, quite similar to the Douglas fir, and then this core have a thinner. Wood density also difference. Okay. Determine method. Actually, I changed a little bit from the previous lecture, because previous one I still use a microscope, but I think in this generation people will use a microscope, so I remove that part. I will replace a new method that is a TAPI 271. We using high-end equipment. We use a fiber length of pulp by automatic optical analyzer using the polarizing lights. We have one before, but it's already broken. Your senior have lucky. After I repair it, I ask them to determine before. We can use the machine to analyze the fiber length, the fiber width, and also fiber length distribution. Okay. But this one is fiber length by optical analyzer polarized. Yeah. Okay, using a projector to project image on the fiber in the glass slide. Hey, is there something wrong with this? I will check the fiber, but this is one. The second one is fractionated method. This one you will learn in this coming lab. I think you will do it for the fiber length. You will determine the fiber length from mechanical part and chemical parts. So we have the Bauer magnets. We have the Bauer magnet as a fractionator in our popping lab. And then you will use it to differentiate the fiber lengths. Okay. Then they have four types. This one I will discuss more detail later. And optical fiber analyzer, something like Kajani. Okay, when we do the projection fiber lengths, we not really average all the fiber. We will use the wasted average fiber length by length. So we will use the length and square it. We divide. So when the length is divide, when we square the length, we have the unit of the meter squared, right? Meter squared. And then we will divide that by the sum of the length. So meter squared divided by the meter, we will get the meter as well. So we will get this weighted average length. So where the L is the fiber length, fiber length. So L is the squared by because the long fiber normally will influence the paper properties more strongly. So that means when we average this, we are not by using, okay, if we not using this method, we use a normal method, we will sum all the weight and divided by the number of the fiber. If we do that, sense mean we'll find that normally in the pulp, we conduct a lot of fine. If we have a lot of fine, when we sum up and divide, then the average fiber length will be lower than the initial effect, the 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 major effect of the fiber length. So on what purpose we want to square it? Because as you can see, if 2 square it become 4, 1 square become 1. 1 square become 1, 2 square become 4. When we plus, if you want to have one fiber length is 2, one fiber length is 1. If we sum up it, we become 3. Divided by 2, we get 1.5. But if we square root it, 2 square become 4. 1 square become 1. Plus together is become 5. 4 plus 1 become 5. 4 divided by the total length. That means 2 plus 1, 3. So now the effect is 5 over 3 is 1 point something. The effect is a little bit higher compared to the original one. Okay, original. 5 divided by 1.5. Okay, the effect of long fiber is more significant compared to the short fiber. That is what we want to see, because normally when you know just now, the paper that I share, the kernel, the cardboard fiber actually is quite long. We add into the recycled paper, we add in, I think it's about 5% or less than 10%, where we can see that the fiber strength is significantly improved by a very little long fiber. That means the long fiber gives very significant influence on the paper property, especially the strength. So that this method is for us to reduce the effect of fine and also a very fine fiber that present in our pulp stock. So length of all the fiber on the projection slide might be measured as a simple method, but time consuming. Wait, sorry. I had to stop for a while. I just stopped for a while. I stopped for a while and also stop recording. I want to show something else. Because I found that this slide maybe is not the latest one that I already changed. Yeah. I want to show the one that I have been updated in school, because this is my laptop. I found that it's something like difference. Photo affecting the fresh pack. That is still in my because I prepare it in USM. Now I'm still in hometown. I can't find the notes there. Why? We just continue what I have now. Then I will give the latest one to you later. Very sorry. Yeah. I thought I already bring back the one. Difference. I think when I changed the slide, I didn't save it over the online slide. Huh? Can you see my slide? What is happening? Me? Something wrong. Wait, wait. I can't off hang already. Hang. My computer is hang. Very sorry. Okay, I restart again. Mm-hmm. To continue to resume the things that record. Okay, I do want to share with you about the using the projector because it's a really time consuming, it's very outdated. I just want to share with you only the fractionation, and the other one is using the using the this material. This okay, there is two I want to share with you. Okay, fractionation. Fractionation is the one method that we're still using until now, and very good method because we will use a separation method by using a tank and also the filter. The filter have a different hole, different size of hole, different size of hole. And the top one is the biggest filters, because hole of filter, and the lowest one is the smallest. So the tank actually is scattered, okay, like this. It's scattered from one top to the bottom. So when we put the pump over here, the small one will be filtered up and go to the second tank, and the small one go to the third tank. And we will actually filter up the pulp in this tank, and sum up. So normally the amount of pulp that we use to do this fractionation is about 5 grams. So we will see the ratio, the proponents, how many pulp is for the longer fibers, the second longest, third longest, and the fine as well. So from here, we will try to use the weight since not use the long. So 5 grams, how many grams remain is the long fiber? Is it 5 grams? Those 2.5 is the longest fiber. So we use the weight. Okay, how about the length? The fiber length, we use the average fiber length for the pump. So everything Sorry, just now my connection also not good. Okay, power magnets, that is what we have over here. So fiber are separated according to the length. Okay, where fiber unable to pass through the screen in its compartment are drained into the file cloth or filter paper and dry and wait. We will dry it and wait it. So the size of the screen selected should be allowed 1/4 of the fiber remain in the compartment with the closest screen. So the top one should have allowed 1/4%. That means at least 25% is remain in the top. They will change, but in our school we only have a 4 screen, so we normally just go through it. And our fiber normally is not highly beaten, so normally we can have more than 25% is a long fiber. You will explain it, and then you can use this method when you go to do your experiment. Remember, you can use back this method. Okay, in the lab, this year you will do the lab. This is the formula how you calculate it. So this is how many percent is the weight that you have, and the total weight maybe is 5 grams. So you see how many grams for the longest fiber length, second longest, third longest, and so on. So the minimum, and the last one, this one actually is a fine. It's a fine. Then it is as a fine. Okay, no fiber length. Very, very minimal fiber length. And this is the tire series screen number. So it's, the lowest one is 100. You have to remember that the screen that we use to make paper, if you had chance to use the paper making machine, the filter that we use actually is 200. The mesh is 200. So 100 is still considered very big. The higher the number, that means how many hole within one inch or 1 centimeter. I think it's 1 inch. How many hole within one is, so the bigger the size, the smaller, the bigger the number, the smaller the size of the hole. So for handshake making, the mesh number is 200. 200 of the hole per inch square. So it's very small. So consider a lot of fine will be removed from the tank. Okay, that's what we want to calculate. And the last one, this is Somerville. When you do popping, you will use this machine. Everybody will have chance to use this machine in our lab. So Somerville fascination only have one slide. Depend on the slit. Underneath, this is the Somerville. Somerville. At the bottom of this water, they're shaking. And then at the bottom, actually, there is a slit. The slit size is about 0.15 mm. Okay, if you still remember that I taught you about the screen. Screen normally they have a fresh back water in order to prevent the clog of the blockage of the fiber on the opening, right? So this one also they flush back all the time. They release the water and flush back, release the water, so to prevent the fiber to clog on the filter openings. And then all the fiber have one size only, so we just want to separate the useful fiber and also the uncooked raw material, only one screen. Okay, separate the fiber into 2 fractions normally used to separate the long fiber and the short fiber. So in recycled paper mill, maybe they have also this screening. So they will screen out the long fiber for long storage tank, and the other one in the short fiber storage tank. Then they will when they want to produce paper, they will use their own formula. How many percent is the long fiber? How many percent is the short fiber to produce their product? Okay, yes. And this one is hardware that I use. It's a Walmart, a variable measurement for fiber. This is the one the latest. So now when we want to study about the fiber properties, the fiber length, the fiber diameter, and so on, we just use one machine. But this machine, I already asked. Your super senior is working in Walmart. My student, Yu Sui Gao, I asked him, hey, how much if I want to buy this machine? Guess how much is it? One apartment, 300, about 380K, about 380K per this machine. Okay, 380K if we have. So we can see the curve of the fiber. We can see the fibrillation, blend ratio, long fiber and short fiber, 100%. And then we can see the percentage of the fine. and then the vessel for the softwood, and then the diameter of the fiber, if you have the cross section, shine, and then others. Okay, so we can determine all this by using, especially the dimension, length, and the width of the fiber. Use one machine, you can see all. And then normally they will get the average of about 10,000 count. They will scan all the 10,000 and do a summary for you. So why we want to use a microscope and calculate the fiber length by ourselves? No need, use one machine. If we have sufficient money to buy this, okay? Fiber thickness. So just now we mentioned about the fiber thickness. Sorry, almost the time already, 12:50. So we will continue this and see you on Tuesday morning, 9 to 10 next week. Okay, that's all for today. Thank you. Sorry, the line is not good, so the smoothness of the class is not so good. Okay, any question from you? Anybody, you have another class, you can stop now. If anybody have any question, can ask me now. So after I settle the thing, I will let you know the, how to say, the grouping, the top chapter for different group. Okay, the chapter for different group. For each group, I will give you later. Any question? If no question, then we will end our lecture today. Oh, then you can all. Oh, thank you.